Hey guys, Mr. Dorado here again with another video lesson for you guys. Today we're talking about section 2.3, which deals with graphing relations using a table of values. So that's what we're going to be taking a look at today. So let's go ahead and jump right into this and start with our first two example problems. Okay, so what are we asking? We're asking to graph a set of domain and range values, then connect the points to graph the line. So domain values, as we remember, that was the x value. So I'm going to go ahead and D here to represent all our domain values. Our range values were all of our y's or our output values. Okay, so I put a small r there just to remember what those are. Now, for some reason, these are showing up as boxes, but be negative signs. So if that's something that you have on your sheet right now, go ahead and change it. If not, then don't worry about it. Yeah, I'm just going to go ahead and change all of those right now to negatives. Okay. Anyways, so we have our x and y values, and now we said that before, every single ordered pair is written as x comma y. So we have a few values here already that we can start graphing, so let's go ahead and do that. So our first ordered pair is 2 comma negative 4. Remember, for each ordered pair, you're always starting from the origin, okay? So starting from there, I have 2 to the right, and down 4. Okay, that's my first order pair. The next one is 4 comma negative 1, so to the right 4 and down 1. Okay, next one, 6 comma 2, so 6 to the right, up 2, 8 comma 5, 8 to the right, up 5, and finally 10 comma 8. So 10 to the right and up 8. Now that we have all of our values, we can go ahead and graph the line here. Let it go as straight as possible. If you have a straight edge, go ahead and use that. Mine was obviously not as good as yours can be because I'm writing freehand, but go ahead and use a straight edge if at all possible. Okay. All right. So just make sure those are all connected, and now we have officially graphed our first graph. All right. So we're gonna do the exact same thing for number 2. So let's go ahead and do that. So my first order pair here is 10 comma 2. I'm sorry, negative 10 comma 2. So starting from the origin, so I'm going to put that one in black right here. So starting from that dot, we're going to go 10 to the left, then down 2. I'm sorry, up 2, which should be somewhere right there. Negative 9 comma 0, go negative 9, so left 9. And we're not going to go up or down, so it's going to stay right on the axis, on the x-axis actually. All right, and then we go again, negative 8, so negative 8 to the left, and then down 2, and just keep going, guys. Go ahead and graph the rest of your values there. So negative 7, negative 4, and finally negative 6, negative 6. Okay, and finally, just go ahead and try your best at graphing a perfectly straight line. Like I said, if you have a straight edge, maybe your ID or something, that can help you graph it properly. Now, there are a few things here that I bring up towards on your sheet either. Remember, this down here is your y-axis, and this right here is your x-axis. Similar on this side. X-axis, y-axis. I like to make sure that those are on there, guys, because we need to get used to understanding which direction we're moving to first. Always on the x first, so always left and right, and then up and down on the y-axis. The last thing I wanted to point out is right here. Notice that I am using arrows. This is signifying that this graph is going to continue. Yes, these table of values only gave me 5 order pairs, so 5 points. However, if we kept going and adding more input values, we would get a lot more output values in which the line would continue. Okay, So now we're actually going to go and create our own table of values because we're going from the algebraic version of it, so just the equation form, into the table of values form. So let's go ahead and see what we have to do in order to do that. So it says to graph lines by using table of values. Choose 5 x values and use substitution to input them into the function. Make sure your x values produce y values that will fit on the graph. Okay, so plot each ordered pair or point and connect them to form a line. Make sure your line is perfectly straight and that it has arrows on both ends. So just like I emphasized earlier. Okay, so this is our first function. Our first equation here is 2x minus 5. Okay, so 2x minus 5. Now we have to first, before we start, do what it asked us to do earlier. It says choose 5 values, okay, for x that we can use to substitute into our function. Now, as a rule of thumb, we usually like to start right here in the center with a 0, okay? Now, it'll become a little more clear why we use the 0, but for now, let's go ahead and take that and go ahead and enter our first value of 0 right in the middle of our table of values, okay? Now, what we also like to do is actually, because this looks like a linear function, I'm actually going to go ahead and go down by 1 as well as up by 1 on my input value, okay? We might have to change that up for other types of problems, but I'll explain exactly why it's a good idea to go up and down by 1 in this particular case. Okay, so we have our values that we want to substitute into the equation. So let's go ahead and do a little bit of substitution. So our first one that we want to substitute in here, what are we doing? We're substituting in -2. Okay, that's our smallest value in my equation. And what does that give us? Well, 2 times negative 2 is -4. -4 minus 5 is -9. And hence, my first number here for my y, my first output is a -9. So we keep going. We do the same thing. Substitute x value in our function and see what we get. 2 times -1 is -2. Minus 5 is a -7. And just continue to do that. Okay? Once again, 0 is 0, minus 5 is 5. Okay. 2 times 1 is 2, minus 5 is -3, and finally 2 times 2 minus 5. Okay, so 2 times 2 is 4, 4 minus 5 is -1. So our remaining values were -5, -3, and -1. Okay, good. So let's go ahead and test those values now. So we have our first order pair. So again, starting from the origin always, for each one of these points, you have to start from there in order to make sure you graph everything correctly. So I'm going to go left 2 and down 9. So let me go ahead and scroll down here. So left 2, down 9. Okay. Now -1, -7. So right about there. 0. So left and right, I'm not going to move at all, but I am going to go down 5. Okay. The right 1 and 3. And finally to the right 1. So notice you can already from there that I am making a straight line. Hence why this chapter is on linear equations and functions, right? We're learning to graph them. So to the best of your abilities, try to graph this as straight as possible. Again, mine aren't all straight because my laptop is very slippery, but hopefully you guys can do a good job. than me. Okay, so I have my graph for this particular function. Okay, so let's just verify that we did all of our steps. So we chose 5 values. Okay, so we chose 5 values and we substituted the input. Okay, so my x value is in the function. All right, now for the second part, we plotted each order pair and connected them to form a line. Okay, so it looks like we did do our 2 steps. So why don't we go ahead and pause the video for a second, and I want you guys to try out number 3. Same thing. Go ahead and use your, and I'll give you guys a quick hint. Go ahead and start by putting in a 0 for your first input value. And actually, in this one, we're still going to go down by 1 and also up by 1. And I'll be a little more clear as to why we do that in a second. So go ahead and pause the video and try this problem on your own. All right, guys, let's go ahead and substitute these values into our function. Okay, so the first one I'm going to do, -2. Okay, so what do I get? Let's see. -3 times -2 is a +6, plus 4 gives me a 10. Right? -3 times -1, that's a +3, plus 4 is 7. If you guys already see the pattern, you guys are way ahead of the game. Okay, so -3 times 0 is 4. I'm sorry, -3 times 0 is 0, plus 4 is just 4. -3 times 1 is -3, plus another 4 gives me a 1. And finally, -3 times 2 is a -6, plus 4 gives me a -2. Now, a lot of you guys might have noticed already, hey, look what's happening. I'm going by how many? I'm going down by 3 each time. But again, that'll be something that we talk about a little further in the next few chapters, in the next few sections. But it's nice to make those connections right now if you do see them. If you don't see those connections yet, don't worry about it. Okay? So let's go ahead and write down our new output values into our function. I'm sorry, into our values. So we have what's 10, 7, 4, 1, and -2. All right, so let's go ahead and graph those. Starting from the center, from the origin, remember, try to remember your vocabulary, guys. We're going to go ahead and graph our first point. So -2, 10, so left 2 down, I'm sorry, left 2 up 10. Now -1, 7, so left 1 up 7. 0, 4, so no shift left or right, but we do go up 4. Okay, 1, 1, so to the right 1, up 1, and 2, -2. All right. So guys, at this point, I hope you guys can start to see that there are a few things going on. In each single one of our graphs that we've been doing, it seems to look like a straight line. And the reason for that is because the functions that we are dealing with are straight lines. Hence why they're called linear functions. Okay? Now, I say that because I want you guys to notice that, for example, let's say for a second, this one I got it completely wrong. Okay? And all of a sudden I thought that when I graphed it, it was supposed to be somewhere over here, let's say. Well, that one is completely out of place. The others seem to be following a pattern, but that one just completely fell off the pattern. So I would definitely suggest at that point to go back and double check your work. Make sure you're doing it correctly, okay? I'm just going to go ahead and plot my point once again. Should be right here. And our final step was to go ahead and draw a straight line through all of our points with arrows as end points, okay? All right, so we have our graph. Now the following two problems are going to be a little more challenging, but we can still solve them together, okay? So let's go ahead and take a quick look at this. So remember how I mentioned before that it's always a good idea to start at 0? Well, that's exactly what I'm going to do. My center value for my input, for my domain x value, is going to be 0. Okay, now in this case, notice right here that we have a fraction. Let me go ahead and highlight this. Notice that we have a fraction with a denominator of 2. Okay, later on we're going to talk about how that number, that whole negative 1/2, represents our slope. Okay, now because we have a denominator of 2 right there, I think it's a good idea to actually go down and up by values of 2. So in this case, I'm going to go ahead and go down by 2, so -2 and -4, and also up by 2, so 2 and, whoops, 2 and a positive 4. Okay? All right, we'll make sure that's a little more clear in a second, but let's go ahead and do that for now. Okay? So let's go ahead, just like before, let's substitute a few values in here. So we have y equals -1/2 times negative minus 4. What do we get? Well, -1/2 times a -4. Negative times a negative are always positive. So it's basically like saying 1/2 times 4. Well, that is just 2. And 2 minus 4 is 2. All right. So let's go. Y equals -1/2 times negative. All right. Let's see. -1/2 times -2 is a positive 1. And 1 minus 4 is a -3. Now, even before going further, so let me go ahead and look at our first two values. Notice between these two values right here, okay? Well, what falls between those two values? Well, that would be a fraction or a decimal, right? There is no whole number between -2 and -3. So pretend for a second that we had put -3 as one of our input values, and we were to try that out, we would have some output values that are decimals, and honestly, we don't want that. This is the reason why I always look to my denominator to tell me how many I have to go down each time or up each time. Okay? So like I said, I'm hoping this will become a little more clear later. If it doesn't make sense, it's totally fine. Let's just keep working at it, okay? All right. So let's go ahead and continue finding the rest of our values. So we have, let's see, y equals -1/2 times 0 minus 4. -1/2 times 0 minus 4. -1/2 times 2 minus 4. That's a -1 minus 5. And the last one, we get -1/2 times 4. That's -2 minus 4 is -6. So we have 4, -5, and -6. All right, so let's go ahead and graph our values on the coordinate plane. So let's go ahead and graph these points. So we have -4, -2, -2, -3, 0, -4, and I'm sorry, 0, -4, 2, -5, and 4, -6. So let's go ahead and graph those. So 2, negative 2, negative 3, negative 2, negative 3. There we go. 0, negative 4, so no shift left to right, but I am going down 4, then 2 to the right, and down 5, and finally 4 to the right and down 6. So once again, guys, let me make it clear why we went up and down by 2. So let's pretend for a second that I didn't go by 2 or down by 2 on my table of values. If I had found something like, you know how in the previous one we did negative 1 as one of our input values, negative 1 would fall somewhere here, which is okay for our x value, but our y value, we're not quite sure where it falls. It falls somewhere between negative 3 and negative 4, but that means we would have decimals or we would have fractions. So we try not to have those. We try to have whole numbers for coordinates, if at all possible, in order to graph a perfect point. Okay, so with that frame of mind now, let's go ahead and think about what should we go up and down by in this next function for number 5. Okay, all right, actually, let me go ahead and finish this other graph real quick so we are all on the same page here. So remember here, just have to graph it using a straight line. Don't forget your arrows. Okay, so that was the last part of that problem number 4. So let's go back to number 5 now. So again, what do we think we should go down and up by? Well, I see that here we have a slope that has a fraction. Okay, so I would definitely say we should try to graph. I'm sorry, we should try to use our table of values with values that go down and up by 3. So let's go ahead and do negative 3, negative 6, 3, and 6. And I think because this value is a little larger, we're going up or down by a larger value, it'll be a little more clear why we do that, and we aren't actually going up or down by 1. So let's go ahead and graph our values, or rather substitute them. So I get y equals 2/3 times negative 6. All right. So 2/3 times negative 6, that should be, let's see, 2 times negative 6 is negative 12, divided by 4 is a negative, I'm sorry, divided by 3 is a negative 4, minus 7 gives us a negative 11. Right, next one. 2/3 times negative 3 is a negative 2, minus 7 is a negative 9. 2/3 times 0 minus 7. Well, anything times 0 is still zeros. And then minus 7 is a negative 7. 2/3 times 3 is 1. 1 minus 7. I'm sorry. Yeah, 1 minus. Well, I'm sorry. 2/3 times 3 is 2. 2 minus 7 is a negative 5. Then 2/3 times 6 is exactly 4. And then 4 minus 3 is a. Oh my god, I keep getting that confused. I'm sorry about that, guys. Let's see. 4 minus 3 is a negative 3. Okay? So let's go ahead and write down our values. So negative 11, negative 9, negative 7, negative 5, and negative 3. So we now have our order pairs. Okay? So let's go ahead and graph those real quick. So let's see, negative 6 and negative 11. So I'm going to go to the left 6 and down 11. And actually, I'm going to go off my graph just a little bit. Not too much, but I'm going to go right there. Okay? Now I'm just making my dots pretty big so you guys can see them, but you don't have to write them that, or you don't have to draw them that large. Okay, so negative 3, negative 9. Okay. 0, comma, negative 7, so right around here. 3, comma, negative 5, so 3 to the right, down 5. And finally, 6 to the right and down 3. All right. So once again, take your straight edge and draw as best as possible. Nope, that still didn't work. That's all right. Just go ahead and draw it as best as possible, guys. Actually, let me try that one more time. All right, let's try that one more time. Well, I guess that was a little better. All right. So I think we basically have completed our graphs. Now, actually, before we move down real quick, I want you guys to start making those connections early. And again, remember how we did before. If we have a linear function, we should be going up or down by a certain pattern. All right, so actually here with orange, notice in this, right? Okay, here we're going down by 2. Okay, now that's not exactly the slope because we actually went ahead and inputted values that weren't going up by 1. However, they do show that the pattern is linear. It keeps going down or keeps going up by the same rate. Okay, so just wanted to make that a little clearer for you guys. Make sure that you guys are understanding this a little better. Okay, so let's go ahead and, oh, I'm sorry. This is going up by 2. Okay, so let's go ahead and move to the last part of our notes. Okay, so it says evaluate the following functions for the given domain values. Now this is stuff that we've done on the day before, so this should be a little bit of a review for us. So let's go ahead and try this out. So first one here, I'm going to highlight, is a G. Okay, so that means I'm using the function G. All right, now let's go ahead and write, but instead of X, I'm just actually going to leave it blank. So 1/3 blank minus 2. The reason I'm doing that is because remember, what am I substituting in for X? A negative 15. Okay? The only difference between this right here and this is instead of an X, I have a negative 15. So here, instead of an X, I'm going to put a negative 15. Okay? So what do I get? Negative 1, I'm sorry, negative 15 times 1/3 is negative 5. Minus 2 gives me negative 7. All right, so we have negative 7. Okay, for our next one, let's go ahead and try it out. So we have p. So we use our function p, which is right up here. We do 1 raised to the x. Now instead of an x, I'm going to put a 0. And as you guys will find out if you plug into your calculators, maybe you already remember this from a previous class, anything raised to the power of 0 is 1. The answer here is 1. Okay? All right, this next one, we are doing f of negative 2. And actually, since that one is very similar to number 6, I'm going to have you guys try it out on your own. So go ahead and pause the video right now and try that one out. Alright guys, let's go ahead and do number 8. Again, notice right here, this is the function f. So I'm going to have to use function f over here. Alright, so what do I have? I have f of negative 2. That means instead of an x, anywhere I see an x, I'm going to substitute it with negative 2. Okay. Alright, good. So again, notice every time I saw an x in the function f, I substituted it now with negative 2 because that's exactly what it was asking for. Alright, let's go ahead and evaluate this. So we get, let's see, always follow PEMDAS when you're solving with only numbers. Okay, we're not solving for a variable, we just have numbers. So we're just calculating here. So negative 2 squared is a 4. Okay, I'm just going to rewrite this part. Alright, now we just have negative 3 times 4, that's a negative 12. 2 times negative 2 was a negative 4, and then minus 1. So negative 12 minus 4 minus 1 is a negative 17. So you just drop this down to show that f of negative 2 was negative 17. Alright. Okay, this one was actually, I think, a little bit easier. Some of you guys might find it harder, but hopefully this will make a little more sense. So once again, remember guys, we've said before, if an equation or a relation satisfies the fact that it is a function, which in this case, notice it passes the vertical line test. Okay, because it passes the vertical line test, that we can say that this is a function. And because it's a function, I've told you guys that we say f of x equals y. Okay, so again, axis and my y-axis. So if f of x equals y, then this number here, whoops, this number in here is my x. So on my graph, I'm going to go look for where x equals negative 4. So that is right over here. So 1, 2, 3, 4, right around there. But I actually want to find my graph because I want to know my y value. So I have to go up right there. So how many values did I go up? I went up 2. So my answer here is exactly 2. All right. Last one before we finish up. We have 3 times g of x. So right off the bat, I know to start off with a 3 because that's just number 3. And I'm multiplying that by g of x. Well, what is g of x? Again, remember, I have that right up here. G of x is 1/3 x minus 2. So let's go ahead and, whoops, wrong pen. Let's go ahead and multiply that out. So 1/3 x minus 2. Okay, now remember, this is multiplication here, and the 1/3 x minus 2 is inside a parentheses, meaning we have to distribute that 3. So 3 times 1/3 is just a 1, so we have 1x. 3 times negative 2 is a negative 6. So our answer here, our 3g of x, was actually just equal to 1x minus 6. Or if you wrote x minus 6, that is also correct. Okay. All right, guys, I think we're going to go ahead and finish off the video here. I hope this started to make a little bit more sense. If for some reason it's not, remember you're always able to go back and double check the video once more. Remember that if you want to test yourself, you can always pause the video and try out a few problems on your own before you actually go together through them with me. All right, well, I will see you guys on the next video.